Hi and welcome to today's video. In this video, I'm going to be talking about how you use information from a titration to calculate the concentration of an unknown solution. If you're not confident calculating concentrations from moles and volume, then the first thing I suggest you do is go back and check out the videos on how to calculate concentration. So, when we look at a chemical equation, just like when we were looking at moles and mass, a balanced equation tells us how many moles of each substance is reacting. So in this equation, it's telling me that 1 mole of HCl reacts with 1 mole of sodium hydroxide to make 1 mole of water and 1 mole of sodium chloride. So if I want to know what volume of sodium hydroxide I need to react with 25 mils of 0.1 mole per litre hydrochloric acid, really, what I'm asking myself is how many moles of hydrochloric acid are there, and therefore how many moles of sodium hydroxide are needed to react with that, and given this concentration, what volume of sodium hydroxide would that equate to? So the first thing is to work out how many moles of hydrochloric acid. So I've got the concentration, I've got the volume. In this calculation, you've converted the volume to litres, which is really important. It has to be done every time. So if I've got 0.1 mole per litre and 0.025 litres, then that's telling me that I must have 0.0025 moles. Now there's a 1-to-1 ratio in this equation because there's equal amounts of hydrochloric acid and sodium hydroxide. So the moles of sodium hydroxide will be the same as the moles of hydrochloric acid, 0.0025 moles. So to work out the volume of sodium hydroxide, it's just a rearrangement of the moles, concentration and volume equation. So volume equals moles divided by concentration. And therefore, that's the volume, the number of moles, 0.0025, the concentration 0.02, and that gives me a volume of 0.0125 litres, which is the same thing as 12.5 mils. Okay. However, in most titrations, what you've got is you've got 3 pieces of information. You've got the volume of the substance that you've pipetted into the flask. You have the volume of the substance that has gone in on the burette, and you have the concentration of one of those 2 solutions, your standard solution. So you need to know which volume is which. That is the first and most important thing. Once you know what you're actually measuring, then you can go from there. So you use the concentration and the volume of your standard solution to work out the moles of your standard solution. Then you can look at your balanced equation and go, if I've got so many moles of this, and the ratio is so-and-so, then I must have so many moles of that. Once you know the moles of your unknown solution and the volume of your unknown solution, which you've worked out through your titration, then it's easy to work out your concentration in moles per litre. You may need to use dilution factors and or convert to grams per litre in your final step, but there's simple steps that are discussed elsewhere. So here's my worked example. We've got hydrochloric acid and sodium hydrogen carbonate. We have 25 mils of HCl and we have 17.2 mils of 0.1 mole per litre sodium hydrogen carbonate. And we want to know the concentration of our HCl. Now, if you've got a question like this, can I please suggest the first thing you do is get out 2 different coloured highlighters and highlight the information for the substance A, in this case the hydrochloric acid, highlight that in one colour. And then the information for the other substance, so for example the sodium hydrogen carbonate, highlight that in a different colour. To work out your average volume of sodium hydrogen carbonate, you may need to first work out your concordant titers. So you've got figure out which 3 titer values are the closest and average them first, and then highlight that in the right colour, because that will save a whole bunch of mistakes. Okay, because the most important thing is that you're keeping things where they belong. So the other thing to be really careful of is how you've laid out your working. Okay, so here's an example. Keep that question in mind, come back to it if you need to. Okay, so the first thing we're going to do is we know the concentration and the volume of our sodium hydrogen carbonate, so we can calculate the number of moles. Moles is concentration times volume. You'll note there again that I've converted the volume into litres, and so I have a number of moles, 0.00172. The next thing is to look at the mole ratio in the equation to work out where we're going. Now, if you think back to that equation, it was a 1-to-1 mole ratio. So the number of moles of HCl is, because it's 1-to-1, is going to be exactly the same as the number of moles of sodium hydrogen carbonate. Then, and only then, will you use the volume of HCl. Because you've got now a number of moles of HCl, you've got a volume of HCl. So you can get that equation out. Concentration is moles divided volume. Here we go. Concentration of HCl is moles of HCl. It's written right there. Divide volume of HCl. That's going to be highlighted in your question. And therefore you can work out your concentration of HCl. If you work out a concentration that is absolutely identical to the concentration of the first thing you had, you've probably made a mistake. Maybe not. Maybe if all your volumes are absolutely identical and it's a 1-to-1 titration, then that might be okay. But if it's not, you're probably wrong. So go back and have a look. Have you taken the volume of HCl and used that in your calculation of the moles of sodium hydrogen carbonate? Have you used the volume of sodium hydrogen carbonate in your calculation for HCl? Right? Those are things that people do regularly. So please don't make those mistakes. The process for calculating concentration from a titration is straightforward if you're very clear about what data you have, what data you're trying to find, and you lay out your working clearly. So this is the most important thing. If your work is really messy, if you don't actually know what you're calculating, if you don't actually know what your data represent, then you will make mistakes. So please, I cannot stress enough, lay out your work neatly and clearly and make sure you really understand what data you've measured, what data you're calculating. Okay guys, I will see you in my next video when I'm going to talk about some common issues with titrations and calculations. Thanks very much, and I shall see you then.